see how this goes. Mentally evaluate all the missing angles, angle measures in each figure. So here's 50, and we know that all the way a straight line is going to be 180, and we can show that really quickly by going over to our sketch page. Whoops, that's not what we want. We want here. Going over to our sketch page, if we have a line and a circle, we can see that the angle from A to B to C, if we measure it, right, this angle here, right, this angle right here is 180 degrees, which makes sense because 360 is all the way around and 180 is halfway around. So a straight line is 180 degrees. So all we have to do is we have to take 180 and take away 50 because we already used up this part. So what's the leftover part? So here we go. Take a quick look at this, right? 180 minus 50 equals 130. So that's 130. Now you're supposed to be doing this mentally. So yeah. All right, here, let's do this one, right? This angle here, angle IEF, well, if that's 30, the rest of this should be how much? Well, to get to 180, that would be 150. So 150 here. What would it be underneath here? Well, if I'm going straight down here with HEF as a straight line, then that's 30. This is going to be 150 also. And then if this is 150 and that's 150, the only thing left over here is another 30. Here, 65, if this is 180 degrees, if we take away 65, oh boy, that's a tough one. Where'd it go? Oh, didn't end up with a, there it is, calculator. 180 minus 65 equals 115. So this piece would be 115. All right, and now you got 135. 135. So 180 minus 135 is 45. So this gap right here is going to be 45. This gap right here also going to be 45. This gap over here will be the same as this one. That's called a vertical angle when they're across from each other. That's going to be 135. We'll talk about that in a little bit. All right. So here we have this figure here. Let's just look at this, right? We have something that's set up. Here's this angle, and this is an angle bisector, meaning it's splitting this angle in half. Here's another bisector, angle bisector. It's cutting this angle in half. I'm going to set this up on this GeoGebra start page here. Let me clear this off. And if I have a line and I have another point down here somewhere and a point up here somewhere, and I want to set up a ray going out here. Let me do this in, great black, going out this way. There we go. So we can see that this ray moves, right? Okay. And so the angle can change. Now we want an angle bisector. So I want, I'm going to put this dotted and I'm going to put it in red. Okay, so here is my angle bisector. I'm going to split this angle in half. And I also want to split this angle in half. There we go. All right. So you can see that as I move this, right, our angle bisectors, it doesn't look like they move that much, right? They don't change, right? It's still the same angle. So let me put a couple of points on here. Put a point up here so that I can work with it. Okay. So if I want to measure these angles out, right, I've got half of some amount and then I have the rest. So let's measure this angle here. B, C, D. All right, I got a 45.29 degree angle. It'd be really nice if I could make that a nice round number. I don't know, like 50. It would be really awesome if I could make it exactly 50. I mean, it would be really super awesome if I could make it exactly 50. Oh, it's not going to let me. Oh, did you see that? I had 49.99. That's pretty darn close. I'm calling it. All right. And then what's the rest of this going to be? Well, if this is 50, then this has to be 130. But let's just double check it, right? Here you go. D, C, A. All right, move that. So it's going to be a little bit less, right? Just because this is 0.5. So that's almost 130 because that's that 0.05 less, right? Great. So the question is, if this is 50, how much is this piece right here? Well, it's half of it. So this has got to be 25 here. So let's measure that angle. So this little section here has got to be 25 degrees, right? This little section in here is 25, which means that this section up here, if this is 130, that's going to be what? 65, I think? Half of that? Something like that. Let's see here. D, C, E. And we'll move that so that we can read it. There it is. It's almost 65, and it's just off by that tiny amount. So if we add these together, the 65 and the 25, what do we get? 65 and 25. Well, 60 plus 20 is 80. 5 and 5 is 10. That's 90. What do you know? Well, it shouldn't be all that surprising, considering that things are not, you know, they don't change as we move them, right? This big angle, F, C, E. And also, isn't it half of the pieces? So as this piece gets bigger, this piece gets smaller. As this piece gets smaller, this piece gets bigger. Right? Anyway, if we measure out angle F, C, E, sure enough, it's a 90-degree angle. Can't really get there. There we go. All right. There you go. We proved it. Okay. Oops, wrong one. There we go. So that's Diego, right? He says it's that this is always a right angle, right? And we try it and it worked, right? Why did it work? Because we're taking half of two pieces that add up to 180. Think about it. If you combined it all, it would be 180. And here I'm taking half of each. So that's going to be half of 180, which is 90. Okay. So that's 7, 6, and 7. All right. Two intersecting lines that create two pair of vertical angles. We talked about this up top. This angle here and this angle here add up to 180. This angle here and this angle here also add up to 180. Here, let's bounce over to a GeoGebra start page and we can look at this. Again, I'm going to take two lines here. Right, here's a line and here's a line. And I'm going to need a point in the middle. Boom. All right. So if I look at these angles, these are just totally random. Right? There's a measurement of that angle. And there's a measurement of that angle. And you'll find that if you look at these two numbers and you add them together, you will get 180. But we shouldn't be shocked by that because that's half of a circle, right? I had 62 there for a second. Right, if it came out perfect at 90, then that would be obvious. But anyway, Okay, like 120 and 60, that's 180. So let's look at these angles then, these other angles. So measure this angle, A, E, D. Hey, what do you know? Also 120. How about this angle, D, E, B, 60.01. So this angle, whoops, this angle goes here, this angle goes here. Look at these. These are matching. The ones that are diagonally across from each other are matching, and they are called vertical angles. If they're diagonally across from each other, they're called vertical angles, and it doesn't matter what I do here, they are going to remain equal if they are diagonally across from each other. All right? Boom. And that's task 9 and 10. Let's look at task 11. One reason mathematicians like to have rigorous proofs, rigorous means really in-depth and intense, right? So that they're infallible. There's nothing wrong with them. We dig in deep, right? Even when conjectures seem to be true, is that sometimes conjectures that are made turn out not to be true. Here's one famous example. If we draw n points on a circle and connect each pair of points, how many regions does that divide the circle into? If we draw only one point, there are no line segments to connect, and so just one region in the circle. Now what they're doing here is they're looking at this diagram down here, right? If I put one point on this circle, boom, there's no line segment, so great, there's no line segments to draw. But as soon as I put another point on here somewhere, I now have two regions. Okay, 2 points, 2 regions. 1 point, 1 region, 2 points, 2 regions. Okay, let's put a third point on there. All right, so now I have, well, it's not 3 regions, it's 4. 1, 2, 3, 4. Okay, so it went from 1 to 2 to 4. And if I look at those numbers, 1 to 2 to 4, I notice something. They look like they're doubling. So each one seems to double. So let's see what happens when we add another point. So here's a point. We're going to add and see if we get, so four points. We ended up with 4 regions last time based on 3 points. Now we got 4 points. So doubling 4 from the last time will give us 8. So 1, 2, 3, 4 plus 1, 2, 3, 4 inside. It's 8. What do you know? Okay, so let's try this. We'll add another one. Okay, so now we go up to 5. And that's what it's asking us to do up here. Right? It's asking us if we draw 5 points on the circle, right? How many are you going to get? So here's what we get. So let me connect these dots. Go here, go here, go. I think that's it, actually. Okay, so we got 5 around the outside. 1, 2, 3, 4, 5. Okay, fair enough. And then I have these parts that are not part. It looks like an upside down star or sideways star or something. 1, 2, 3, 4, 5. Those are the triangles that are not part of the star. And then I have, so we're up to 10. And then I have 1, 2, 3, 4, 5. Those are the points of the star, right? And so that is another 5. We're up to 15. And then the one in the middle, so 16. So it went from 1 point, 1 region, right, to 2 points, 2 regions, 3 points, 4 regions, 4 points, oops, 8 regions. So you can see how this number is doubling. 1 region to 2 regions to 4 regions to 8 regions. And now we're going to, and we did 5 points. And we came up with, whoops, didn't mean to do that, 16 points, whoops, 16 regions. And it seems like this is working. It's doubling each time, right? That formula would look something like, right, the formula would look something like this. Let's see if I can find it. All right. It would look something like this. It would be like the number of regions equals the number of points. No, wait. It would be 2 to the n minus 1, right? See what that looks like. No, not quite. See if I can change that. Oh, can I change it? It's not letting me get to it. Cancel. All right, well, we're going to delete that because that's wrong. All right. All right, 2 to the power of n minus 1, because you get 1 less. So this would be 2 to the 1 less than 2, which would be 1, 2. 2 to the 1 less than 3 would be 2, which is 2 to the second is 4. 2 to the 1 less than 4, which is 3. 2 to the third power equals 8. 2 to the 1 less than 5, which is 4. So 2 to the fourth is 16. So this seems to hold up, right? Oops, didn't mean to delete that, right? All right, so now, so that was our conjecture. Test it with 6 points on a circle. Here we go. We just have to put some more, we have to put another point in here. So here we go. Now we got this, here, 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 and that's it. Here, let's move. Can I move some of these points around? Yeah, make it even out. There we go. Okay, so easier to count this way. Let's start in the middle and go out. And we'll start just to the right side of this. We go 1, 2, 3, 4, 5, 6. Okay, great. Now let's go out to the next layer. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, and then out here, 25, 26, 27, 28, 29, 30. So 30. So hang on. So it all right, well, it doesn't want me to do that. I would like to be able to edit that. But 6 points turned into 30, not 32. We expected it to double up to 32, and it didn't work. Okay, so that was that. Move on to the practice.